Alright? Now let's look at slope field, gradient field, or direction field. Alright, so note that slope field, direction field, and also what do I call gradient field looks like that. And every slash that I draw on the graph, okay, represent the slope of that particular point. Okay, so if I were to give you a graph like that, okay, so when you look at it, I've got all the slashes to carry the same gradient, am I correct? And it is the positive gradient, right? So if I were to gather all these slashes together, that is when I'll see a linear as a solution, am I correct? If I were to join these slashes, that is when I'll see a linear like that. So if it is a linear that I see, solution to my differential equation could have been y equals to ax plus c. Yeah, so if you were to perform differentiation, that is when you're going to have dy over dx equivalent to a, and a being any constant. So when you look at it, alright, my dy over dx, my differential equation, or my slope field, okay, it's equivalent to a, and this is independent of x and y, right? That is why you don't see x or y in your dy over dx. So what happens if this direction vector that you're going to be given, right? So when I see such a thing, that is when I'll observe that I will be getting a quadratic solution. And why do I say it is a quadratic solution at turning point x equals to 2? It's because one possible solution is like that. Am I correct? Yeah, so when you look at it, solution that we expect to write would be y equals to a in bracket x minus 2 in bracket square. Am I correct? Because it is the quadratic solution that I should be getting. So what would my dy over dx be? It would probably be like, if I were to differentiate this correctly with respect to x, that is when I'll see 2a in bracket x minus 2. So one possible answer that I could write as my dy over dx would be a in bracket x minus 2, because it is obvious that I'm going to have a turning point at 2, and I'm going to have my a to be more than 0 because it is a smiley quadratic. Okay, it is a what do I call? It is a positive quadratic. Okay, so when you look at this one simply means I have my dy over dx. I hope I have my slope field to be dependent on x. So it means to say when you change your x, you're going to have your slopes to change. So when I have, for example, okay, x to be 2. So 2 minus 2 would give me 0, hence the gradient for x equals to 2 would always be a horizontal line because it has got a gradient of 0. So how do I observe that whether it is dependent on x or y, or it is not dependent on anything? You have to look at the slashes. When you look at this one, you have got the same gradient for any x given to you, and you have got the same gradient for any y given to you. Therefore, I have my dy over dx to be independent of both x and y, so it is just a constant. But when you look at this one, for the same x, different y, for the same x, you're going to get the same gradient. It means to say your gradient is only dependent on x. Right? So how did I get this negative slash and also positive slash? This one, okay, this column itself give me x equals to 1. So when I have 1 minus 2, I'm going to get a negative, am I correct? Negative 1. So it means to say dy over dx is equivalent to negative a. Hence, it will be a negative a gradient that I got. And accordingly, when you test out, like, x to be 0, you're going to have negative 2a, and again, you're going to have, like, more slashes that are negative. And you will do the same with x equals to 3, x equals to 4, and that is when you will get positive gradient. So graph like that, okay, means column, column with the same sort of gradient. It means to say that you have got your dy over dx to be dependent on x, alright? So when do I know that I have got my dy over dx to be dependent on y? Let's look at one example over here, okay? And this is a partial question. So when you look at it, I've got the same gradient for the same y value. Did you observe that? When y is equals to 2, I have got a gradient of 0. When y is equals to 3, I have got a negative gradient. When y is equals to 4, I have got an even more, negative gradient. And when y is equals to 1, I've got a positive gradient. And when y is equals to 0, more positive gradient. And when y is equals to negative 1, I have again, positive gradient. So when you look at it, every row that I've got will carry the same gradient. So it means to say I am dependent on y, because every time I change my y value, that is when I'll have a change in gradient. Hence, you would expect to get a dy over dx like this. But you might be asking, how would I know to write such a thing in exam? Okay, so the first thing you tell yourself is that I have my dy over dx to be dependent on y. So how then should I do it? Just like what I have been doing in the previous, okay? Tell yourself the solution that is possible and then differentiate accordingly to look for the differential equation or to look for the slope field. So when I look at it, I actually saw this and I actually saw that. Am I correct? And I have got a zero gradient when y is equals to 2. So if this is what I observe, okay, I I am reminded of like, the exponential graph of y equals to exponent negative x, you see. And why is it a plus 2 is because if you were to observe the graph of y is equals to exponent negative x, it has got an asymptote at y equals to 0. But over here, when I look at it, I actually have an asymptote of y equals to 2. Hence, I decided y is equals to exponent negative x plus 2. So if this is what I have, I'm going to go dy over dx, and hence I'll be getting negative exponent negative x, because 2, if you were to differentiate with respect to x, you would then get 0. So if this is what I got, I'm going to have my dy over dx to be equivalent to negative y plus 2. So some of you might be asking, okay, how did you actually get this one? Isn't it negative exponent negative x that you got earlier? You are right. If I were to rearrange this one, okay, did you see that it is actually exponent negative x equals to y minus 2? So what then about negative exponent negative x? It is simply negative y plus 2, which is this. So then you will ask, how would I know to live in terms of x like that or in terms of y? Again, please be reminded that when I look at the slope field, I know that my dy over dx would change with the change of y. Hence, I must have my dy over dx to have y in it. You get what I mean? Alright, hence I'm going to have my dy over dx to be equivalent to negative y plus 2. Right, so how do I know whether this is correctly done? Okay, let's test it out. With y in my dy over dx, it means to say every time I change my y, I'm going to get a different gradient. So when y is equals to 2, I will have negative 2 plus 2, which will give me dy over dx equals to 0, hence horizontal slope. Okay, horizontal line. When y is equals to 3, positive 3, I'm going to get negative 3 plus 2, which will give me a gradient of negative 1, hence I get negative slope. And when y is equals to 4, negative 4 plus by a 2 is a negative 2, again I get an even more negative, what do I call, gradient. And when I have got my y to be 1, I'm going to have negative 1 plus 2, and that is when I'll get dy over dx equivalent to 1, positive 1 gradient. And when I have y to be 0, I'm going to have my dy over dx to be equivalent to 2, and even more positive gradient. Okay, so how am I to know what dy over dx to write? Check the slope field, okay, and see whether it is dependent on x, whether it is dependent on y, or whether it is independent of both x and y. Okay, so what happened then, like I told you, if my dy over dx is dependent on x and y, you will see such a thing. Okay, so when you look at it, it means to say every change of x, I'm going to have a different gradient, and every change of y, I'm going to have a different gradient again. So how then do I plot, how then do I actually sketch, a slope field? This is what I have done earlier. Okay, I'm going to have, I'm going to look at my y-axis first. When it is y-axis, okay, I'm going to have my x to be equivalent to 0, am I correct? So the moment I have got x to be equivalent to 0, disregarding what y value is, I'm going to have a gradient of 0. Hence, I've got horizontal line plotted. I have had no slopes on the x-axis because on the x-axis I have got y equals to 0, and obviously I cannot have y to be 0 because the moment I have got y equals to 0, my dy over dx will be undefined. Okay, so how then did I draw these positive slopes and negative slopes? Okay, look at it this way. In the first quadrant, I'm going to have positive x and positive y, am I correct? So if it is positive x divided by positive y, I should expect to get positive gradient. In the second quadrant, it is negative x and positive y. So if it is negative x divided by positive y, that is when I'll get a negative gradient. Okay? And how then did I get my third and my fourth quadrant slopes? I'm going to go with again third quadrant, negative x, negative y. Negative x divided by negative y will always give me positive gradient. And what about for the last quadrant? Positive x, negative y, positive x divided by negative y, it will always give me a negative gradient, right? So why are these lines here already? Why are these slopes here? Okay, so this one simply means the gradient when x is equals to 1, y equals to 1. So 1 divided by 1 would give me a gradient of 1. What about this one? Okay, this is when x equals to 2, y equals to 2, 2 divided by 2 will give me a gradient of 1. Okay, and what about this one? This is when x is equals to negative 1, y equals to negative 1. Again, I'll get a slope of 1. And when you draw this, it is simply x equals to negative 2, y equals to negative 2. So again, it is of gradient 1. Yeah? And what about these negative slopes? This one I'm drawing, okay, simply means negative 1, x, y equals to 1. So negative 1 divided by 1 will give me a negative 1. What about this one? Negative 2 divided by 2, I'm going to get a negative 1. Alright? And what about for this one? It is x equals to 1, y equals to negative 1, hence again a gradient of negative 1. And what about this one? X equals to 2 and y equals to negative 2, hence a gradient of negative 1. Alright? So what about other places? Like, sufficient to draw just like that? Of course, no. You have to fill up more. So what about for this position? Okay, this one would give me x equals to 1, y equals to 2. Am I correct? So you will then get like, dy over dx to be equivalent to half, and half should be less steep than 1 earlier. So if I were to draw it, I'll be drawing something like that lah. Okay, and what about for this point? This point would give me x equals to 2, y equals to 1, hence I'll be getting a gradient of 2, and a gradient of 2 means it should be steeper than my 1 earlier, gradient of 1 earlier, hence I'll be drawing something like that. Okay, right, okay, maybe this is a bit too much, okay, like this. Alright, and we'll do the same to the rest of the points, okay? And this one, okay, this point here simply means x equals to negative 1 and y equals to 2, hence it is negative 1 divided by 2, negative gradient it is, and I'm going to get something like this, okay? And for this point, it is x equals to negative 2, y equals to 1, so it is negative 2 gradient, and I'll be getting something like that, okay? And you explore yourself on this point. This one is x equals to 2, y equals to negative 1. And you're going to have this point to give you x equals to 1, y equals to negative 2. And this one would be x equals to negative 2, y equals to negative 1. And one last one would be x equals to negative 1, y equals to negative 2. Okay, I'll leave the 4 dots for you to fill up your slashes. Okay, so this is about slope field.